All right.
Okay, so maybe this time through I'll catch what I screwed up on the first time. Um, or maybe he doesn't even show it.
In the previous video, we learned how to set up simple pathfinding in Unity. In this video, we'll go over how we can make our nav mesh dynamic so that it will update to changes in game. We'll use the obstacle component to easily make moving objects part of our nav mesh. We'll also have a look at generating a nav mesh at runtime in the case that you don't know the layout of your level beforehand. Also, this video is sponsored by Unity. So let's jump right into it. So here's an even more stripped down scene than the previous video. All we have is a ground plane and a player. The player has a nav mesh component that we set up in the previous video. And we also have a nav mesh object in here with a nav mesh surface, which we can go ahead and hit bake on, and we can see.
Okay, so what that's referring to is this was a member example or example 1 from last time. And if we ran it, our pieces tried to intelligently find the shortest path to the destination. And if I clicked over here, like that. Now, for example 2, if I double click that, save on that. This right here is just a floor, and I got these squares here. That's takes part in the video. I'll probably just go ahead and leave them there so I don't have to recreate them. And if I look at the floor, you can see we got our mesh renderer on that, box glider, our player. You got your glider on it. Haven't really mentioned that, but these having the gliders on there is important. The mesh renderer, then nav mesh agent. And again, this is what helps it to intelligently move around on your screen. You can change the speed of it, just like we saw last time, and even the obstacle avoidance. You know, what kind of radius, the height. I'm not sure about what quality and priority do. Radius and height is kind of obvious. You know, when you get close to something, you know how much do you avoid it. If you got quite a bit of radius, it might not go anywhere. And then we got this player controller script from last time, where if we click on something, then our player will go. Now I had to actually add this on here. I don't see where he actually said to do that, but I added this script on from the previous example, for example 1. And then nav mesh up here has our nav mesh surface, and that's when we do the bake, bakes it.
Right away that it bakes a nav mesh on our ground. As always, you can use the link in the description if you want to get the example scenes as well as the nav mesh components. The scene that I'm using here is example 2. So before we start diving into obstacles and changing the nav mesh in real time, there's another feature that I want to show you. It's called volume modifiers. If we go ahead and right click on a nav mesh and hit create empty, we can now add a component here, and I'm going to search for nav mesh modifier, and I'm going to select the nav mesh modifier volume. A volume modifier is basically a way for us to mark a certain part of our nav mesh with a specific area type. This way we don't have to link it to a particular object, but we can just say that anything within this bounding box will have some kind of area type. We can easily edit the volume by clicking this edit volume button, and now we can...
Okay, so what it's talking about is if I do go to example, yeah. But if I drop something on here, let me go back to one. Let's see. So I dropped on this this cube right here, so it would block that. But if you want to drop on something that is invisible, but still has this area that blocks off that they can't go through it, then that's how you do it. So you right click here, create empty. And here's our position of that. And you click add component, nav mesh volume, nav mesh modifier volume. And then you can specify, can't walk through it, and the size of it. Now if I come back to my nav mesh and bake that, see how it blocks out this area as something you can't go through. You can change the size of this, so forth, but that's how you don't have to have a physical mesh taking up space to say you can't go through this. Example that might be water, maybe
a gate for a key, maybe.
Gate, yeah, exactly. So there's a lot of times where you maybe even you want a mesh there, but you don't want that mesh to be what's actually used for your obstacle. So you define your own. Now I'm really surprised on this. This is a script they've written, and they're still really tweaking a lot of the features of Unity. You'll see the new versions come out quite often. But I'm really surprised by this, that where's the... Well, let me see.
can drag on the sides here. I'm holding down Alt to scale uniformly. And we can also select what area type we want to override with. If we go ahead and select not walkable and go back to the nav mesh and hit bake, right away we are going to see a hole in our nav mesh. So that's just a really cool feature that I wanted to show you.
I thought there was some place where we could choose a different shape, but I'm obviously missing it.
I think that was a little further along.
Was it? Okay. So that probably implies that this maybe just adapts itself to whatever shape you pick. I'm guessing. Let's see. Game object, 3D object. I'll drop on a sphere. And let's see if it's a rectangular solid again. And click add component, nav mesh modifier volume. Nope, it's always that, I guess. At least at this point. Okay, so let me go back to this example 2. Yeah, that was a different script, wasn't it? It was the obstacle, wasn't it?
But so far we've been hitting bake every time we want to change the nav mesh. What if we have moving elements in our scene that we want to affect pathfinding? For this we use obstacles. So let's rebake our scene here, and let's go and create one of these obstacles. We'll right click in the hierarchy, go 3D object and select a cube. Let's reset the transform on this cube. Let's move it up by 1 on the Y, and let's change the scale to 2 by 1 by 2. I've also prepared a material that we can use under materials, and I'm going to drag this in. I'm then going to rename our cube to obstacle, and as expected, if we select our nav mesh, it's going to completely ignore our obstacle.
So what we're talking about there is, let me see, delete that, delete that, delete that. This is just a cube I dropped on there. And then they tell us to do these settings, 010, 212, and we're going to make it a nav mesh obstacle is what they're referring to. But they're not there yet. And then we're going to have a script to move it. But again, just dropped a cube on there. The material was under the example 2 obstacles material, and I dragged and dropped that. I forget, it's either up here or over here. I dragged and dropped it, and that's what gave it that color. But until you put something on it, like I said, it just it isn't even part of the navigation piece.
To change this, we'll go and select our obstacle, hit Add Component, and this time we want to add the nav mesh obstacle component. If we open this up, we have a few different settings. The first one is the shape. Here we can select between a box and a capsule. In our case, we're using a box. We can then change the center and size of our obstacle, but I'm just going to leave all of those as is. And now if we go and select our nav mesh, we can see that for some reason it's still not reacting to our obstacle. That's because of a very important setting under our obstacle called carve. The reason for this setting is that we have kind of two obstacle modes. This is because we can use obstacles in two ways. If we leave carve unchecked, we'll just rely on what we refer to as obstacle avoidance. This is something that our agent component does, and we actually have some settings for it right here. Obstacle avoidance is when our agent will do its best to avoid obstacles that are nearby, but it won't actually include it in pathfinding. So whenever it's creating a path, it won't take our obstacles into consideration. Only once it gets close to one will it kind of try and steer away. The second way is using carve. If we check this, our obstacle will actually go ahead and cut out a piece of our nav mesh. And so our agent will plan its route around our obstacle from the very beginning. To show you the difference between these two methods, I've gone ahead and created a bunch of obstacles. Each one of these have a script that will animate them back and forth, as well as a nav mesh obstacle component. Currently carve is set to false. If we go ahead and play, we can see that the obstacles start moving. If we select our nav mesh and hold down Control and select our player and go to the top right of our game view to make sure Gizmos is enabled, we can actually see that when we click around, the path that our player is calculating is visible. And because the obstacles aren't set to carve, we can see that our agent won't actually calculate a path to try and avoid them. It will only kind of try and move out the way once it gets close. If we select our player, we actually have some settings under the nav mesh agent that configures this behavior. If your game is relying a lot on moving obstacles, I suggest you play around with these settings. Here we can adjust the radius and height of the agent, as well as the quality of the obstacle avoidance.
So what they're saying there is with our player, since it has a nav mesh agent on there, that radius will affect how close it gets. When they had that as 0.5, then it went up quite close to it, but change it to 0.77 and it's a little bit better. But again, the idea whether you use that carve or not is whether does it plan, or just when it gets close to something, then go around it.
We can see that by increasing the radius, our agent will now take a greater path around the obstacles. But of course there is another way. Let's select all of the obstacles and enable carve. We'll also make sure to disable carve only stationary. If this is enabled, the obstacle won't carve out a piece of the mesh if it's moving. And since our obstacles are moving all the time, we definitely want to disable this.
Okay, so after I created this, I did a ROM to begin with. Realized I didn't have my move it script on there, so I dragged it up here and created this move it script, and I'll double click that just to show it. It's nothing exciting. Yeah, I think I double clicked it. I have direction indicating which ways it's going back, going forward or backwards, and that's where I multiply it times -1. I have my vector 3 position I'm recording off and my speed. Then I retrieve the transform position of whatever object this is attached to. So the cube, for example, I'm retrieving that position. I'm changing the position of the x, where I'm adding speed times direction. And if direction is -1, it'll be going the other way. And then if the position.x is greater than 10, or, 2 pipe symbols there, means or, the position.x is less than -10. That means I need to turn around. And that's why I say direction is equal to direction times -1. And then I reset this transform.position equal to my variable position. So that's what causes it to move back and forth. And I also have my nav mesh obstacle on here. So after I created all that, then I'd simply right click on this and choose duplicate. Right click on this, choose duplicate. And right click on that, choose duplicate. And get that to go off. There we go. Okay, so now I've got all 4 of those. So now they tell us to highlight those and carve. I think they said to check, but they said uncheck the carve only stationary. Let's see if that's a true statement. Yeah. Okay. And I'll click my player, hold down my control, and click nav mesh. And Gizmos is on. It gives us that.
If we then again select the player and the nav mesh and hit play, we can clearly see that our obstacles are now changing the mesh. And if we press on some point on the map, that our path actually gets calculated around these obstacles. Pretty cool. So that's how we can add obstacles to our game. But since we are editing the nav mesh at runtime, this isn't very performant. It's fine to use for a few objects, but we want to bake as much as possible beforehand. However, sometimes we don't know the full layout of our level before the game starts. This is often the case if you're procedurally generating a level. Luckily, we can easily generate a nav mesh at runtime using this same system. So if we go and open up example 3, this scene is even simpler. All we have in here is a ground, a nav mesh surface, and then I've gone ahead and created this level generator script.
Okay. This is where I am messed up on the other one, so I wanted to make sure that I've got everything in sync. So I got this, nothing there, but when you run it, so what did I screw up in the script? Yeah, there it goes. So it generates a level automatically. Now it's not very. I thought it was intelligent before I ran it the first time, but it isn't too intelligent because it can sometimes put your character right in the middle. Now it's building it based upon these little squares right here. So this over here, where these are all together, each one of these is a separate piece. So it's not like it's trying to figure out what pieces to come up with here. It's just the same square just randomly put in different squares. And if you look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think. But that's what it's based upon. Now, what their code did is it said, okay, it's a 10 by 10. And they defined the public game object wall and player in this manner. And that is so through your script over here, you could drag and drop anything on here. For example, if I had a different mesh, it probably wouldn't make any sense. Guess maybe I've cleaned it up a little bit. Just trying to find my werewolf. But with the script designed that way, then for your level generator here, you just drag and drop your new mesh onto the wall like that. And if I run it, That's curious. It says wall, doesn't say the monkey. Wall, didn't I drag and drop it? Monkey, okay, so it actually says monkey now. I bet I was still running my game when I did that. I'm bad about that. Then you see monkey heads everywhere. So again, that's the beauty of setting them up this way, is you can easily change it to a different shape. I'll drag the wall back there. Down here, this is based upon random numbers, and that becomes important in a lot of things in game development, because you got things that happen randomly. If everything happened exact same occurrence, then it wouldn't be very, very fun. You'd know exactly when a ship is going to go across the top of the screen. You'd know exactly when the enemy's going to appear. So it adds that unknown to it. Now, the random.value returns a value between 0 and 1. So to say we only do this when it's greater than 0.7, well, all the values greater than 0.7, which is about a third of them. So this will be true a third of the time, which means it'll come down here. It'll calculate my position, my wall. Couldn't tell you any more about it than just what you're seeing there. I'm sure there's some kind of mathematics behind it. And then instantiate creates an instance of it. And it passes in the game object that we got declared up above here, right there. Passes into position, and then some of these transforms and quaternarian identity to position it correctly. Then it comes down here and checks if a player has not been spawned. Then it says to create an instance of the player. So that's what this instantiate does. And then it says player spawned is equal to true. Down here, that's the generate level. And goes through there. We also, up in this void start, and he'll talk about this in a minute, we put surface.build nav mesh surface. And where that surface came from is we created another public up here, nav mesh surface. And in order to do that, you got to have the using Unity AI or using Unity engine.ai. And this creates another item on here, so that we can drag the surface onto that. Okay, so let's watch the video some more.
Script. What this will do is if we hit play, it's going to generate a random level and place our player somewhere in this level. But of course our player is unable to move because our agent is not placed on a nav mesh. So we want to make sure that our nav mesh surface is updated after our level is generated. To do that, I'll open up my level generator script. As you can see, I have a bunch of code in here, but mainly what I'm doing is in the start method, I'm calling a function called generate level. This function is down here, and it's basically just going to loop over a grid and determine whether or not we want to spawn a wall for each point on the grid, and we also make sure to spawn in the player. But that's not really important. The main thing that we want to do is make sure that we also update our nav mesh after our level has generated. So under this piece of code is where we want to update our nav mesh. To do this, we first need a reference to our nav mesh surface. And remember, whenever we're dealing with nav mesh through script, we want to go to the top and make sure that we're using Unity Engine.ai. Then we can go and add a variable which is going to reference our nav mesh surface. So we'll create a public nav mesh surface and we'll call it surface. Then we can go to the point where we want to update our nav mesh, and all we need to do here is write surface.build nav mesh. And that's it. This is the only function that we need to call in order for the surface to go ahead and rebuild. If we save this, go into Unity and make sure to drag in our nav mesh surface in the new surface field. We then go to our nav mesh and just hit bake right now. So now it's just an empty nav mesh. And if we then hit play, we can see that the nav mesh perfectly fits our level. And we can now start moving around our agent in this procedurally generated maze. Super cool. And we can regenerate this as many times as we want. And one of the coolest things about this is that it's only going to cost us right when the level is generated. We aren't spending processing power each frame on trying to fit the nav mesh to the level. We only do it once. So that's pretty cool. That's pretty much it for this video. In the next one...
No, he simply just does not say how the player works. See if I generate this. And I click over here. See, our character doesn't move. So our player does instantiate it, creates an instance of it, but doesn't actually move. That's because for that prefab, the script is not attached to it. So you think I could double click player here, open up the prefab, and put my player controller down here, which might seem to work, except for it wants a cam and an agent. And the idea behind a prefab is it's not necessarily directly associated with any scene. You should be able to drop the prefab anywhere and reuse it. So by having these on here, that causes us some issues. But then when I put the code in to try to look for or do a find on the camera and the nav mesh agent, that didn't go well. Let's try that again. Okay, so I got my prefab opened here. What in the world? It's my one from the other day. Let me just make sure I have the correct one open. Yeah, I guess it is. Okay, so I got my update there. It's my set destination. So I wonder if P will work. Is it based upon the camera? It's not based upon the camera. The P, that is. Not based upon anything. Okay, let me run that and see. No. How I got around it is on my scene here, I just went and dropped my player on here. Example 3, I think it was. I had to drop my player up here. And then I'll set the camera. And I'll link the nav mesh agent to itself here. Now it'll move. I guess it gets confused when there is no path. That's interesting. Okay, so let's go on to the part of the next video, because now I have time to show it. The animated character. And to just give a kind of a preview of this, this is example 3. So go to example 4. And we got two separate objects here. And I want my character to go from this object to that object using pathfinding. Well, obviously if I bake this, and I rotate it a little bit, you see that there's no way that it should go over to the other side. Famous last words. Okay, it doesn't even have the move in there. So let me go to my player and drop the script on there for moving. Player controller. Drop my camera on there. And nav mesh agent to itself. There we go. As I click over here, it just cannot get there. Now my radius, you notice that it gets put close to the edge. Again, you can control that with the radius here. 0.77. Yeah, I thought you could. I swear in the last class that when we changed that to 0.7, it didn't go as close to the edge.
I'm pretty sure it's going off of the center of the cylinder. And
Yeah.
the fact that the edge is not technically an obstacle.
Right. But still, when we changed it before, it's because a 0.5 would be like from the center out. I'm assuming this is a distance of 1. Let's see if that's a true statement. Yeah. Maybe 0.77 wasn't enough. I don't know. That should definitely not let you go that close.
Yeah, it's because it doesn't count as an obstacle. It's the edge instead of the obstacle.
Oh, so if we drop one of those obstacles on there again, that's when. Oh, it was an obstacle we were working with, wasn't it?
Yep.
Because it was one of those moving cubes. Remember how it looked like you had to smack right into it before it go around? Yeah, you're right. Okay. If I had a memory. I'm probably looking right at it. Where's the radius? Oh, there. Okay, so we need to create a link. And it's pretty easy how you create a link from here to here in order for your pathfinding to find a way across.
In the previous video, we learned how to make our nav mesh change at runtime. In this video, we'll learn how to use links to connect together multiple nav mesh surfaces. We'll also finish things off by implementing an animated character to replace our cylinder. Also, this video is sponsored by Unity. So let's jump right into it. So as you can see here, I have a simple scene with two ground elements. Both of these are just simple cubes, and I've gone ahead and named one ground 1 and the other one ground 2. And if I go to my nav mesh here, I can hit bake, and you can see that both surfaces are walkable to our agent, but there's of course a gap between them. So if we were to select our player now, we can see that we have the nav mesh agent, and I've gone ahead and added the player controller that we created in the last video. And if we play, we can move around one of the ground planes, but there's no way for us to go to the other one. To change this, we can use a nav mesh link to connect them together. We'll go to our hierarchy, right click and hit create empty. We'll reset the transform, and let's rename it to link.
Okay, so what we're doing, if you could hear all that broken up, is we're creating an empty. So right click over here, create empty. I don't think it has to be attached to your nav mesh. No. And give it a name, link. And I'll choose the move here. Okay. Then we're going to be adding a component for a link.
Let's also add a new component, and we want to add a nav mesh link. And if we now zoom in, we can see this illustration of two arrows connecting 2 points.
Okay, so we click add component, and nav mesh link is right here. And you see a little line going across there, indicating from this point to that point. Well, that's not the correct bridge to go from over here to over to here. So they're going to have us rotate it. And let's try it again. Should have just typed in numbers. I can't even see that. But that's negative 90. You kind of see the little black line there?
Just barely.
Yeah, it's like right here. Not really easy to see. It's a little bit better here in this video.
We can of course control where we want these points to be. I'm just going to take the entire object and hold down Ctrl while rotating to make it span from one surface to the other. I'm also going to go ahead and move it up so that these rings here are placed right on top of the surface. And this is...
Okay, so let's move this up. Yeah, we got our rings right there then.
It's pretty crazy, but that's pretty much all we need to do. If we now go into our game,
they actually make it pretty easy with all their scripts that they add. And click over here and it does that. Now you might look at that and say, well, that's pretty fast how it goes across there. The idea is it's not crossing a bridge. The idea is that it's like zooming to another level is what they indicate. Or like you're jumping, which means you'll be faster going across.
And hit play, we can now click on the opposing surface, and our nav mesh will use this link to transition from one to the other. You will notice that if we click over here, our agent has to go through the link in order to reach that position. If you look closely, you can see that the agent speeds up when using the link. This is the agent exhibiting jump-like behavior. When creating a nav mesh link, we aren't creating a surface. Instead, think of it more like a teleporter, where when we meet the start of the link, it will simply quickly move the agent to the other side of the link. There are also some different properties that we can modify on our nav mesh link. Most importantly, we have the width. This allows us to make our link wider so that our player can use it over a greater area. If, for example, we wanted to make
the width they're talking about here is 0. So that's why it has to go directly to the middle. So if you change that to 10, you see how wide it's become. And if I run that, maybe. Did I not bake? Better have to bake again.
It reset to 0, by the way.
Oh, it did. Okay. Well, what did wrong there? 10.
Now you may have to bake it.
Let's see. No. See how it went straight across on this edge that time?
Yep.
So anyway, you can make that as wide as you want. And okay, I was wondering why I was saying it. Gizmos was on. Because that's an invisible link there. So when you're seeing the game, you shouldn't see that at all.
pretty much this entire gap into a link, we would just increase the width in order to do that. And if I now hit play and tell our player to move, you can see that he just uses the shortest path there. We can also choose whether or not we want the link to be bidirectional. If we disable this, our player will only be able to use the link one way. In our case, we'll be able to walk across here, but we won't be able to transition back. And then, as with the other NavMesh components, we can also choose a area type for this link. But right now we're just using our link to connect between two parts of the same NavMesh. We can actually use links to connect between multiple NavMesh surfaces. An instance of where this is particularly useful is if you are loading in your level in chunks and you want each part of your level to have a separate NavMesh. Well, then every time you load in a new part of your level, you can simply connect it together with the old one using links. And everything should work just fine. So if we go ahead and select our NavMesh here, we can actually duplicate it. I'm going to name the first one NavMesh 1, and the second one I'm going to drag to the top and name NavMesh 2. I'm then going to select my first ground here and add it to a layer. This one is going to be ground 1, and I'm also going...
Okay, so duplicating the layer, or this empty. Right click on it, choose rename, NavMesh 02, and let's move it up here. And I had us go to NavMesh 1, I believe, and choose the layer.
Going to add another layer, which is ground 2.
Okay. So we went to layer, add layer, and went to ground 1, and ground 2. I think they come back here and they point this to ground 1. Let me see if that's true.
Then if we go to our ground 1, we need to assign ground 1 here, and for ground 2, we'll assign ground 2. If we...
Okay, so back to ground 1 here, that'll be in this layer, ground 1. And ground 2 will be in this layer, ground 2.
We then select our first NavMesh. We can make sure to not include ground 2, and we'll hit bake. So now this only...
So if I grab the first one here, NavMesh 01, remember the include layers. You can choose that, and you can tell it not to include ground 2. And if you click bake, you see that just applies this one. Guessing we'll do the same thing with the other one, excluding the other piece, but let's see.
Only includes the first ground, and for our second NavMesh, we can make sure to not include ground 1 and hit bake on this as well. And now this only includes our second ground. So if I disable one of these, we can...
Okay, so let me do that first. Come over here. I want to choose include layers and then shut off the other one. So shut off one. And see bake there, bakes that. And they're having a shut off in NavMesh 02.
You can see that they are now on two different NavMesh surfaces.
Okay, so they're just demonstrating, even though they're both showing here. If I come over here and shut that off, see how, like that. And if I shut this off. So they are two completely different ones now. They're separated.
And if we hit play, you'll see that our link still works just fine between them. So that just opens up a whole nother world of possibilities.
Okay, and they're just indicating if you play it, then it still works the same. He said it opens up a whole world of possibilities. What that means is that you could have a whole series of objects here with their own nav mesh on it, and they're completely different from each other, and your character can still go back and forth between them.
And now that we have a great amount of control over our nav mesh, it's time to replace this boring looking character with a cool animated one. To do that, I'm going to open up example.
And we'll stop there because I don't want to get in the middle of that. What it really amounts to, though, is when you got a player here. Player is not just a mesh. It's a lot of things. It's a transform, the cylinder, the mesh, capsule collider. You got your mesh render, pathfinding, obstacle avoidance, materials. So it's a lot of different items. You can delete the mesh part and leave everything else. And that's what we're going to see, is that we can keep all the same components that go along with this moving, but add in a character and even have it being animated. Is there any questions on any of that?
No.
Okay. Did it make more sense that time going through?
Yeah, it made a lot more sense going through it the second time.
I still get them mixed up. That's why I start making my little notes about click here, click there, click here, click there, and then I thought I need to figure out if I can have sound play through Zoom, make my life a little easier. So, well, we'll go ahead and stop there.